So for the second one right here, what's the rate law? Rate is equal to k times x to an unknown power and y to an unknown power. Okay, so would you like to try it out? See if you can find out the exponents and the overall order. So in order to find out the exponents for x, experiment 1 and 2 will be great because the concentration of y is kept the same. So this is a double, this is a quadruple. It's a square. Okay? If it's a double and a double, that's the first order. They change the same way. But if it's changing in a squared manner, quadratically, then it is square. To find out the exponents for y, we would choose 1 and 3, right? This is what? Halved? Yes, it's halved. And the rate? Not changed. Zero order. No change when the concentration is changing. The rate is not changed when the concentration is changing. So that means your final outcome is just that rate is equal to k times x squared. Okay? All right. Now, I'm going to say something which you may not even consider about it, but I want to say it first so that next week when we come back, it's going to make more sense. This is considered the overall reaction. Okay, like if you mix 3x and 2y's together, bam, you're going to make y2x3. Okay, all right, that's the overall reaction. When you have an overall reaction, you do not need to pay any attention to the coefficients when we are writing Rate's law. You do not. Okay? Like those, the 3 and the 2, they are not related to our exponents. No. Okay? Now, like I said, you probably did not consider this at all. And why is Mr. Chen talking about it? Well, it's because somewhere down the line, which I am intrigued by, well, it's okay. All right, now. Okay. Oops, sorry. So that's a question right there on your page 10. It goes like this. It goes like this. You say, hey, there's a reaction. W plus Y gives you K. Okay, somewhat arbitrary. And then we are going to talk about mechanisms like, hey, you go through multiple steps in order to make the product. So those are the 3 steps, all right? Now, first, and for today only, I want you to have a very special attention on any step that is considered slow. Because this step, the slow step, is known as the rate determining step. Okay? For example, why is a slow step the rate determining step? Yeah, if you're shopping, how about this? You have shopping experience. Like when you go check out at a cashier, okay, there's a person scanning your items, and there's another person to put your items into the bag. And now, let's just say the one scanning the item is very fast. It's easy. Bagging the item is very slow. Slower, at least. Which person should be used, or the speed of which person should be used to gauge how fast you can leave the grocery store? The speed of the cashier, the scanner, or the bagger? The bagger, right? Because he is slow, you are, like, no matter how fast the scanner is, he is going to dictate your speed of leaving the store. So this is the reason why we say, oh, the slowest step, or the slow step is the rate determining step. Number one. Number two, well, this is the overall reaction. These are not overall. We call these the, well, we have a very special name for this. This is called elementary step. The little step, the actual steps to make your products. When you have elementary step, you will use the reactant and the coefficient to write down your rate law. For this example, this is it. You look at a slow step, there's only one reactant, so the rate equals to K times W. Mr. Chan, you did not include the Y. I don't, because Y is not part of the slow step. Okay? Meaning what? Meaning that, well, the order of Y in this reaction is 0, basically. Okay? Which we don't write it, but if you want to write it, that would be it. Okay? If you want to see it like that, it's implicit. It's first order to W, 0 order to Y. So with elementary steps, we will use the coefficient to write down the rate law. But we never ever write down the rate law based on the overall reaction. So make sure you know there are two types of reactions right here, like verbally or on paper, and you do not confuse them.